Good evening, everybody. So let us start our lecture tonight, and I will finish early tonight, a few minutes early tonight. Okay. Let us see that how early we can finish tonight. And according to our syllabus, in last lecture, in last lecture we discussed a reference parameter. If you were not present in our last lecture, please watch my recorded video and do practice. Without practicing, you will not be able to understand. Okay, the test question for test 2 and 3 and final will be something creative, interactive test question. Okay, as long as you understand the concept, you will be able to answer. If you do not understand the concept, you will not be able to answer. Okay. And we know that quizzes 4 and 5 are due this weekend. Please do not wait for the last hour and take it as soon as possible. Okay. And you know that next week this time will be your test 2, right? Next week this time will be your test 2. Yes. Okay, do not miss it. And by this weekend I will pass you a study guide, but I asked you only to practice only 3 programs. As long as you know that 3 programs, to write that 3 programs confidently, then you will be able to do well in your test. Okay. So tonight we will start on recursion. Recursion is a good topic, but let me see, maybe I have skipped something. Maybe I'm skipping something. So before recursion, okay, there is a parameters, overloading and guard base, this slide, and function stack. This should be repeated. Let us see. Okay, we already discussed this, but there are some slides. Let me go this quickly for 5 minutes, within 5 minutes. So we know that a method, right? A method or a function is a block of sequential code that executes something, and a method has a header and its body. So in C++, C# and Java, this header line is a little bit complicated. This is the method modifier. Okay, this is public, this is static modifier, and this public modifier, this is return type int, and then this is the method name, and these are the formal parameters x and y, and this is the method body, and this is the return statement. So this return statement is correlated with the return type, right? If return type is integer, then this function will be able to return x plus y. If we do not want to return something, then we put void, right? If you have a void return type, then you cannot have any return value, but you may have a return statement. That is a critical interview question, that if you have a return type void, can you have a return statement? Yes. As long as you do not return any value, you may have a return statement. Usually the return statement goes to the all the way end. It becomes the last statement, but you may put something with condition. We discussed reference pattern. Okay, sorry, maybe I opened the last wrong. Which one? Is that we discussed in our last week? Same thing. So we discussed like reference parameter with an integer type variable. It is the same thing applicable for a class or any other type variable. Okay, one more thing, maybe I forgot to discuss out parameter. Okay, out is same thing. Okay, but the reference for the ref keyword, we need to initialize the value in the method, caller method. But if you use out keyword, you do not need to initialize. It is optional. Only single difference between ref. Is that the one I missed? So what is that on function parameter? same thing. Actually, we discuss method overloading, right? We discuss method overloading. Then the last thing I see that garbage collection in Java, garbage collection is automated. Okay, that older programming languages like C++ did have, C++ has a destructor. The destructor, when an object goes out of use, the destructor destruct the object. The destructor is used to delete the object so that memory space become empty, so that for the next available variables or object. We discuss this. So garbage collection is one thing that in our program Java has a GC method, garbage collect automatically, that we do not need to handle garbage collection in Java for like even small program, but for huge program, very large program, we may need to collect garbage and need to free our memory space manually. I worked sometime in an insurance company, so they have in an insurance company, when they load a program, it loads sometimes thousands of customers record information. So when we have a car insurance, right? So they have all of your records. So your address, old address, your driving history, your social security number, who are your family members, your spouse information, a lot of information, right? So in that case, so if you load like several multiple customers record, then program becomes slower. So in that case, we want sometimes to create a garbage collector method, so that when this programmers become slow, then we click on the button and then it deleted the garbage. Garbage means unwanted, that is that unusable, unused program. So we discuss call by variable, call by value, and call by reference, and then method overloading we discussed, right, earlier. A function can have multiple numbers of method with same name and okay, but not same signature. Then the function becomes different in terms of their argument type or number of arguments, right, but not in return type. Okay, and method overloading happens within a single class, one class, and there is another term is called method overriding, right? Method overriding happens between parent class and child class. Whenever we have a body or implementation of a method in a parent class, and if you do different implementation in your child class, then we override the method. In C++, in Java, we use override keyword, and in C Sharp, we use override keyword. In Java, we use override annotation. And another thing is that there are some programming languages, there are operators overloaded. So for instance, the plus sign, C++ did not have, maybe recently it may have, but did not have plus operator overloaded. We know that a plus operator is usually used to add two numeric numbers, right? But we see that in our hello world program, or in our recent program, we can use plus operator to add a number with a string, right? Or a string with another string, right? This is not adding, this is called concatenation and connecting, okay? So the single operator can be used for multiple purposes. Still it works as for adding two numeric numbers, and still it works to add or concatenate, not actually add, concatenate to string. So some languages like C++ and C Sharp allow method operator overloading. That means you can write a function, for instance, the plus operator that can extend its functionality. For instance, like adding two numbers. For instance, adding two complex number. we know that a complex number has two parts, right? One real part and another imaginary part, right? So if I want to add two complex number, how do we add? Real part with real part and imaginary part with imaginary part, right? So that addition is different than regular addition, right? So you can concatenate, you can rewrite a method that will help you to use this plus operator to concatenate, to add two imaginary numbers, complex numbers, that is called, right? Ax plus bi. But Java does not allow operator overloading, but this course is not, we are out of bound to discuss operator overloading. If you take data structure or advanced level course, algorithm, then you will learn how to overload operators. So we discussed this thing, that's it. So let's see what else. The function stacks, maybe this is simple one. Okay, the function stack, okay, this is a 1321 course. So it says how a function works. When you call a function from another function, mainly like the host main method is the caller or host method that calls other methods, right? So when like main method calls another method, for instance method 1, and if the method 1 calls another method like method 2, and method 2 may call another method, for instance is calling another method, or for instance the print method, then what happens actually, this sequence is kept on a stack. After 2 weeks maybe you will learn about stack. After this topic we will learn about stack is a data structure. Then maybe we can come back here to discuss this topic, then it will be easy for you to understand. Stack is a memory location that keeps the value temporarily. For instance, a stack is something, for instance, whenever you are reading a book, simple book, right? For instance, you are reading something or middle of something, then if you got a phone call or if you call by someone else, then you leave the book with a bookmark, right? And then when you come back, you start from the remaining place, right? By looking at a bookmark. So bookmark is manual stack. But sometimes if you give attention, then you don't need to use bookmark, right? What you do is just give attention. Okay, I have read until this line, third line or fifth line, right? Then when you come back, then you start from the next line. So when a program calls another program, then it keeps the track whenever it was previously on a stack. Then in the reverse order, it take out the position. And for instance, here let us see that if we start from the beginning. So here let us start from here, the main method over here, right? Main method, it works for Java. In Java, M is in lowercase and C# is in M is in uppercase. So whenever this main method, it calls method 2 and method 1. So what will happen? You see that main method here, it will put it pushes into the active stack, has 3 things to do. So it knows that it has to do execute the main method 2 and then method 1 and then print. So it put this in a stack. So after that, what happens when at the time it calls method 2? So what happens? It goes to the method 2 right here. So method 2, inside method 2, what it gets? It finds a print method. So it executes the print method. So print method, it prints method 2 was called, like this part. And after that, this is deleted. This method is done, right? Execution is done, then it is removed from the stack. After that, what does it do? It returns to the main method again in method 1. Okay, so it is see that cursor position is main method 1. So at this point in method 1, so what it goes to method 1. So method 1, it goes here, it see first print statement over here. So it execute the print statement, and it execute the print statement, then it says print method 1 was called. This is the second line is executed. After that, it calls method 2 again, right? So at this point, it goes to method 2, then here is method 2. Then what happens? It goes to method 2 back again. And method 2, what it does, it prints something. So it come back here and it prints that line. And after that, it goes to your original steps, last one. It will be deleted from stack, and it goes to method 2 over here. And at this point, method 2 is done, so it goes to print this over here. And after that, it will go to this. And at this point, method 1 was executed, so it will be removed from my stack. So then at this point, it comes to this statement, finish. So this one. And then it prints finished. After that, it will come over here. It comes over here and it deletes the method 1. This method 1 is executed and is done. Yes.
Shouldn't all be on the same line? Shouldn't they all be on the same line since this is print, not print line?
That's good catch, but yeah, remember that it is print line. It should be print line. Yes, good catch. Okay, today let us start a new topic, and it is very important. Okay, recursion. Okay, when the process of recursion is that when a method calls itself, then it is called a recursive method, and the process is called recursion. Okay, recursion is a process that if a method calls itself. Okay, the ideal example of a recursion method is factorial. Find the factorial of a number. How do we find factorial of a number? For instance, factorial 6. We know that factorial 6 equal to 6 times 5 times 4 times 3 times 2 times 1, right? And in shortcut, how the factorial 6 can be found? Factorial 6 equal to 6 into factorial 5, right? You can write factorial 6 equal to 4, 8, 6. Okay. So for any number, for instance, here it says factorial 75. So factorial 75 equal to, computer does not calculate 75, factorial 75 like 75 times 74 times 73 times like level up to 1. It does not work that way. It would take a long time. So what it does, it calls itself, it repeat the similar process that say factorial of 75 is equal to 75 times factorial of 74, right? For instance. And then we need to understand, we need to figure out factorial 74. It's a little bit better, less complicated, small number, right? So then it makes factorial 74 equal to 74 times factorial 73, right? Then it will go to factorial 73 equal to 73 times factorial 2. See that how the number is getting less complicated, right? Smaller. So this way, where should we stop? So in general, we know factorial of n equal to n times factorial of n minus 1, right? So even if n equal to 0, then what is that? We know that factorial of 0 equal to factorial 0 equal to, and factorial of 1 equal to, yes, factorial 0 equal to 1, factorial 1 equal to 1. These are our base case where we stop. We do not calculate any factorial number of negative, any factorial of any negative number. Okay. So a recursive function, it calls itself until it goes to its base case. Okay, when you step on or step down on a stairway, how do we do? How do we walk? We step down until the base, right? At the last. So what happens? Don't try at home. Even if you reach base and still you walk in the same fashion, you will fall down, right? And when you step up on a stairway, right? We stop, we start walking differently when you go to the base, the top, right? So then when you come to stop, and again if you try to raise your feet, you will fall down. So yes.
Is factorial 1, 0?
Yes. Factorial 1 equal to 1.
1, it's 1 is equal to 1.
No, factorial of 0 equal to 1, I said. Did I did mistake?
0 factorial 1.
Factorial of 0 equal to 1.
Okay.
Factorial of 1 equal to 1. Did I tell something mistake? Wrong?
No.
Did I say factorial 0 equal, factorial 1 equal to?
0 factorial is 1, yes.
Yes. Okay, so in order for recursion, we need three things. Okay, for the recursive operation, we need three things. Number one, we need to, at some point, we need to stop, right? At some point, you need to stop. Then we need a base case. At the base, we will stop, right? And we need a terminal condition that will tell us that yes, I am on the base condition, right? And it must progress towards the terminal. It needs to converge to the terminal, to the base. If it diverges to the base, it will not work. Okay. So for instance, making factorial of 5, we say factorial of 5 equal to 5 into factorial 4, right? Equal to 5 into 4 into factorial 3, right? Is this way we will go 5 into factorial 5 into 4 into 3 into 2 into factorial 1, right? We can stop at 1 or we can stop at 0. You can say 5 into 4 into 3 into 2 into 1 into factorial 0, right? So our base is 0 or 1, we are converging to the base. But if you say otherwise, for instance, factorial 5 can be written as factorial 6 divided by 6, right? Can I write factorial 5 equal to something different way? I can say factorial of 5 equal to 5 times factorial of 5 minus 1, 4, right? So by this way it will converge, it will be forwarding, progressing to the base, right? So at some point I can say equal to 5 times 4 times 3 times 2 times 1 times factorial of 0 factorial. I can say this way, right? So in this fashion it is converging to my base, but I could say like this way, equal to 6 factorial of 6 divided by 6 divided by 6. Still it is factorial 5, right? Right? But this way I am going diverting to the base, right? I am going far away to the base. So this process will not work. You know, still it is, what is the value of this one? Still factorial 5, right? Factorial 5 equal to 5 factorial equal to, but this is not an ideal way for recursion. It's not an ideal way, not a way for recursion. So what is the ideal way? We need to go this way. So a recursion method can only solve the simplest problem called the base case. Okay. We must have a base case. Base case, it depends on us. We'll see that shortly. Okay. Usually divides the problem into two pieces. The part it can immediately be solved and the remainder of the problem. So base case is the case that where this is a common known part, okay, that we know, everybody knows, for instance, and that can be solved quickly. That will set up base. Okay, let us say, for instance, factorial say. So in order to find factorial of a number, we will set up base either 0 or 1. Even we know that what is factorial of 2? 2, right? So that in case is this case, I could set up factorial of 2 as base, but I usually do not do. We should not do that, okay? For instance, if someone asks you, so what is your college year? How many years for how many years you are studying in college, okay? What will be the answer? If someone asks you what is your college year? Yes, freshman, right? Okay, but if you answer something indirectly that, okay, next year I will be a junior. Is correct, right?
Yes.
Is expected correct, but the answer is not correct. So you are twisting your answer, right? Maybe there may be a reason for somewhere you may tell this. For instance, if you go for a job interview, you may tell them, oh, next year I'm going to be a senior or junior, right? For getting a favor, but that is not a real answer, right? Your answer should be straightforward. So that is your base. Okay, so our base should be straightforward. Okay, so in order to make a factorial program, we will consider base either 0 or 1. We know that factorial 0 equal to 1 and factorial 1 equal to 1. Okay, and then how the remaining part will do. Okay, so we will start a method like can give a factorial and it will take almost all factorial methods that work with argument variable. So here if say this is my factorial method and they say if n equal to 1, then it will return 1. That means what is it doing over here? That means if I reach to 1, right? That means if I want to factorial 1, then what is my factorial 1 value? 1, right? Then this result is 1, right? Otherwise, what will happen? If it is not 1, then what will happen? Else, the second part is the interesting part, and that is the recursion part. Otherwise, or you say else, or you cannot say else, straightforward, you can say return n times factorial of n minus 1. So this is here where is the recursion happening. So when a method calls itself, right? So in general this method will be, so the whole method will be like this. Factorial of n can be any number. For instance, when you want to provide 5 n equal to, then it will call 5 times factorial 4. Okay, so here is the recursion happening. Yes. But how long this will go? So that when you call for factorial 5, then it will do 5 times factorial 4. And then factorial 4 will call 4 times factorial 3. Yes, what is the question?
Isn't return 1 supposed to be 1 line down?
Oh, so you're saying this is okay as long as you write it's okay. You're asking this?
No.
This?
No, the return of the number 1.
This?
Yes.
Yes, you can write in one line. Not both way it will work. It will work both way. Okay, so this is one way. So for instance, let us see how we can modify this program. Can we change this base? Do you understand me? Do you understand my question? So is this the only way to find factorial? No. There may be multiple. What is another way? Quickly you can tell me.
Using a loop.
Yes, using in the for loop we can do it, right? But we are not using for loop. For loop is not recursion. Okay. So here we can change base, right? For instance, if n equal to 0, then what will happen? Return. We know that factorial, this is a 0. If is that means n equal to 0 means when we are reaching to 0, that means factorial 0 equal to 1. So instead of this, even I could say if n equal to 2, then what will be my return value? Factorial 2 equal to 2, right? If I set up n equal to 3, then return value will be 6. If I set up n equal to 5, then return value will be 120, right? It will work for any number greater than 20, greater than 5. Okay, but we want to find any factorial of any number, so this is why we should set up our base as a really, that is really base, either 0 or 1. Okay. So this is the program, factorial of a number of a program. So if you get this, you should be able to code it, right? And the last, there are many slides, last few slides, what it will do that it will just use stack. Okay, so then it is showing me when you call factorial of 4, for instance, if n equal to 4. Okay, then if you will be factorial 4, then it will print 4. It will put 4 over here, and then what happen is it will check is n equal to 1? No, right? So then it will go here. It will result will be n times factorial n minus 1. Then it will go 4 times factorial 4 minus 1 equal to 3, right? Sorry. Then it will come back here and it will print n equal to 3. It is not printing factorial of n, it is printing just n. And then n equal to check, condition check will be checked here. Then it is not equal to 1, right? So then it will go back to the else, and this time it will call 3 into factorial of 3 minus 1 equal to factorial 2, and this way it will be, see the pending work. So how this works? So go to this slide, and how long it will go? How long it will go down? How many loops it will count? Until it reaches to 1 equal to 1, right? When it say find is 1, then it will return this statement, right? It will be, this will true, right? So then it will say return 1, right? So now is the magic over here. Then it will be backtracking. Okay, it will collect the previous result. So what it will do now, it will collapse the stack. That means it has some value to the stack, and then it will return this one. This one will be used as factorial at this place. At this place, instead of factorial 1 equal to 1, right? So then it will come here, this factorial, it will return, that value will be deleted and it will be put over here. You see that how that value, the factorial 1 equal to 1, that value will come here 1. And then what is the result of 2 times 1 equal to 2, right? And the next phase it will be, these 2 will be put over here and this value will be deleted in the stack. So this is value 2, so this value will return result So this value will be deleted and it will get 3 times 2 6, right? And then it will do this one and it will replace factorial 3 by 6, 24, right? And the next time it will come here and it will replace factorial 4 equal to, that is 24. So this is the final value. It will be printing 24. This will be a 4. Do not be confused because it is saying it is printing n value here, and factorial value is printing all the way n, last one time 24. Do not be confused, okay? So okay, two things. Okay, there are only a few more slides. For instance, one of them is that a general program error. Sometimes it may happen if you do not converge to the base, your program will overflow the stack. Okay, so while finding factorial of n, you should use n equal to n times factorial n minus 1. That is a convergency. But if you do divergency, right, factorial n equal to, you can write factorial n equal to, you can write this way, factorial of n equal to factorial of n minus 1 divided by n minus 1. Sorry, n plus 1 divided by n plus 1, right? It is true, right? But that way is divergency, right? It will never reach you to the base case. If you want to try to program that way, then let me write it here. So for instance, we know that factorial of, n factorial equal to n plus 1 factorial divided by n plus 1, right? This is the brush, I need to brush. Which is the brush one? Should delete. Actually here is factorial n. So this is the way of divergence. It will not converge, okay? This is not a good way, so it will not work this way. Factorial recursive method will not work this way. So here we are on this slide. So stack overflow means that it will overflow the stack and it will make an error. So that before I go, I want to give you this one as a challenge question. So this is very simple, like already it is over here. You will try this program at home, okay? So I have already added my code over here. This is my code, okay? I added over here. So let me show you that how can we do factorial number. Same thing for Java and C#, okay? There is no difference except the print statement, okay? In the last class we discussed this, right? Let me see if I find my code over here. NOPQR recursive method, right? Okay, recursive power factorial. Okay, recursive factorial number. Okay, that's good. I have at least maybe 3, 1, 2, 3. Okay, I have 4 different way to find factorial of a number using recursive. Okay, so if I run this program n equal to 5, so let me see that if it gets the output. Okay, so using fact1 method, factorial 5 equal to 120, using 3 factorial 5 equal to 120. Using this method, factorial 5 equal to 120. So all of this work. Okay, so let me explain this and then let me give you the difference. So for instance, this one is my name is fact1. Okay, so for this one, okay, for now remember that all factorial or recursive methods are argumented that has argument, right? Parameter pass. Okay, so here it says if n less equal to 1, then return n. What does this mean? So n is an integer value over here, right? What is the value for n minus less or equal to 2? What is the possible value? Tell me some values that is less or equal to 2.
2, 1, 0.
Yes, 2. Okay. 1, 0, right? Okay, so if we are not going to negative, so we don't need to consider. So here, if n we reach to factorial of 2, then that is value is 2, right?
Yes.
So then we can return if n less or equal. Okay, so if we say n equal to 1, then what will happen? Return n, right? It will return 1, right?
Yes.
So for 1 it will return 1, and for 2 it will return 2. And then for other cases it will call itself, right? Factorial of n minus 1. So this is a way, but this is not a good way, so this is seems confusing for these two. Okay, the best way it should be, we can say factorial like this one, you may say this one. We know that factorial 0 equal to 1, so you could set factorial base equal to 0, or here you could set factorial 1. If 1 equal to, then you could return actually 1 or n. Whatever you return, it will work. Here there is another case. If you want to use while loop, that means while n greater or equal to 0, you call factorial 2 itself by n minus 1. And in factorial equal to n times n minus 1, it is returning factorial. This is a way. Okay, so here recursion is going here on this line. Recursion makes over here on this statement. And here you can say another way. If n equal to 0, then return 1. Otherwise, you can say total equal to total times total equal to n, total equal to total times factorial of n minus 1. Recursion coming over here, there is another way. This is the very straightforward way. Okay, what is doing here? It say if n less or equal to 1, then it's returning 1, right? And else what is doing? N equal to n times factorial of n minus 1 and returning 1. So you can do that way actually. You can do return over here. You can return n times, find factorial n minus 1. Someone has a question like, could I do this way? Yes. You have a question, right? So can we put in one line? As long as you put enough space, it will work. Okay, I'm giving this code on a Replit so that you can practice it. Okay. Let us do is Java first and factorial recursive factorial 4 methods, right? Example 1 Java. Okay, it is working. And let us convert it into C sharp. Do I need to convert it, or you can do it? In C sharp. So if we convert this code into C sharp, what changes we need to do? Can anyone please help me? Okay, no matter what is your lab, you need to understand code in all two languages, C++, C sharp and Java. Okay, we need to change this line, right? We need to change this line. That's it. It works. Okay, so please practice this, okay? And if you know this, then there are some other factorial, popular factorial program is that finding Fibonacci series. What is the Fibonacci series? Anyone knows about Fibonacci series?
The additional last two numbers before it.
Yes. The third number is the sum of the previous two numbers. Some mathematicians argue that Fibonacci series start from 0, and then some people say that it will start from 1. So let us consider with 1, okay? So the first one is 1, second is 1, previous is 0, the 0 plus 1 equal to 1. Then third one will be 1 plus 1, 2, right? Then fourth one will be 1 plus 2, 3. Fifth one will be? 9. No. Fifth one will be 2 plus 3, 5. Sixth one will be 3 plus 5, 8. The next one will be 5 plus 8, 13. The next one will be 8 plus 13, 21, and it progresses like that way. Okay, the Fibonacci series, what it does actually here, it calls the Fibonacci method, and like this way, if n equal to 1, then less or equal to 1, then return 1. Otherwise, it calls Fibonacci n minus 2 plus Fibonacci of n minus 1. This is the code, okay? This very recursive, most of the recursive methods have only few lines of code, but you need to understand these few lines. Okay, and there is another power factorial for this one. This is on my slide. This is on the slide, right? Power factorial. For instance, x to the power y. X raised y, right? Now 5 to the power 3 equal to 5 times 5 times 5, right? Equal to 125, right? So this program is here. So power factorial. It works that way. So it is recursion is going here, right? It is equal to x, and it is returning y minus, calling y minus 1. Okay, and let us see this program. Okay, this is the last one I want to discuss tonight. So this one, what it is doing over here? Give attention please, last 2 minutes, okay? So what is returning? It is printing 1 times 2 times 3 times 4 times 5. 4, 5, not times, okay? 4, 5, 6, like this way, right? What will happen? You see over here, but if I so this is printing this number is an ascending order, right? From smaller to higher. So but if I do this, what it is doing over here, see that? Okay, then so you see, look at over here what I'm doing over here. So instead of this line, okay, so if I which one is another one? Else, if I give this statement over here, and if I do this, what will happen? Okay, I will need time for this one. I will discuss this one later. Okay, so you will get this code if you go to my Replit account. No, not Replit. I go to my GitHub account, github.com/CSITEd experts. Then if we go CSE1322, so both in my maybe C# and Java, both Java and C#. This package has this program, recursive method. So all methods are over here. Okay, so do some practice, get my code from over here and do some practice. Okay, next week and in next lecture we will discuss something more. Anyone has any questions so far? This is an interesting, and this factorial process is the foundation of many other programs. Okay, so please practice it. So tomorrow there will be a delay. So there will be 2 hours delay. KSU will open 10 a.m.